On YouTube there are many tests of different types of ammunition. Based on theory you have heard earlier, you know these tests are not valid for all rifles, and the test itself should not be based on a single group of 5 shots, as shown in this video. Using scientifically grounded model of understanding accuracy, you should sometimes shoot even up to 100 shots per group to be sure that the result is significant. By significant, I mean statistically accurate, or more technically saying that the p-value is less than 0.05. At this point you might wonder, why did I shoot groups of 5 if I just said that it's too few? The answer. First, I said that sometimes you need 100 shots. For example, in this video, the difference is significant after just 20 shots with different brands of ammo. However, with reloading the same type of ammunition, the difference is not significant even after 100 shots. Second, if we visit the official F-Class Precision Shooting Competition website, we will see that the competition are held with 5 groups of 5 shots each, and the winner is one who is the best average across all 5 groups. This is a decent standard, and I shot at least 20 rounds. Taking another box with 20 rounds wasn't within the budget. By the way, it is interesting to note that in Ukrainian gun store Praporshchik and Ibis you can easily buy individual rounds, but in the more elite Stvol store you can buy only the whole box. This leads to the third point. Since these tests are self-funded, I cannot extend them to scientifically ideal level, no matter how much I would like to. Fourth, the 50-meter distance for accurate ammunition turned out to be too short, even the group for 5 shots. It was often impossible to see exactly where the bullet hit, and there were frequent situations where one bullet would hit another. Out of 150 groups, there was 35 cases of bullet-in-bullet hits in group of 5 shots. Even with the worst Hunter Arms ammunition, it happens 3 times, and the most accurate GGCR it happens 4 times, meaning only was one a flyer. Let's see this group one more time. However, shooting groups of 3 is also not an option, because if we take the smallest and the largest groups, calculate their data and average these deltas, we will see that the differences can be as much as 100% of average. For groups of 5, the average delta will be 50%, and this is the average value. The largest group can be up to 9 times bigger than the smallest for a group of 3. This is also included in this average value. Thus, on average, the sigma for a group of 5 will be ranged from 1.25 to 1.87, while for groups of 3 it will be ranged from 1 to 2 MOA. The final point is the rate. Since I'm conducting this test only within the context of my own rifle, and do not need to present these values as some sort of standard, the actual values don't matter to me. What is important is comparison, that is the relationship of one thing to another, not the specific numbers. This means you can shoot even groups of 2 and then average this group, the rating will be more or less the same. The same applies to the mean radius. Let's check this by comparing the rating and graphs of different systems. For example, in the extreme comparison of groups of 3 and 5 using the mean radius, we get the same coefficient. The same goes for comparing the muzzle brake and the suppressor. The truth is, if we use the groups of 3, the difference will be more askew because we are discarding 2/5 of data. In Brian Leeds' book, Applied Ballistic, the second edition, there is a table showing the dependence of the average group size on the numbers of shots. The solid line represents the air test, and the dashed line represents the data from Hornady ammunition manufacturer. After shooting 150 groups, I can add my data in the form of dotted lines. It's clear that the data does not match exactly, and this is not theoretical science, but applied science. However, the trend dynamics are quite comparable. If we do the same for the mean radius, we see an increase of only 23% from 3 to 5 shots, and 21% from 5 to 10 shots, despite the fact that the mean radius value may even decrease as the number of shoots increases. In the US Army, they shot 10 groups of 10 shots for a single target sheet. Also, you can clearly see the shift in point of impact due to the suppressor. Because very small group often occur, people may think they are super shooters or have a super rifle. I have such groups too. As part of the 1 MOA all day long challenge with AI-10, I got 0.11 MOA for the first 3 shots, although the result worsened afterwards. But I was shooting not in a windless range, and outdoors was 30 degrees Celsius heat with the Mirage. Plus, I was shooting from some local Blooden setup, because according to the challenge rules, you are not allowed to use the vice or exceed the 10.5 freedom spawns with bipod. But bipods can noticeably improve accuracy. The longer the base, the more precise your aim can be, providing better stability. If you look at a rifle on the bipods as a lever system, it's advantageous to extend the bipods as far as forward as possible, even beyond the rifle's body. Some competition shooters use special bipods with extended bar, pushing the support point up 1 meter ahead. But at the end of the challenge, I had nearly 2 MA over 10 shots with a high-end DD5V5, and 1 MA with my average Xeon 15. However, these 10 or actually 14 shots were taken in the ideal conditions with the perfect setup and ammunition. The real average accuracy of my rifle is about 2 MA for a 5-shot group across all ammunition types, and 1.5 MA for 3-shot groups, which align well with the numerous other tests of modern weapon system for wasting ammunition like AR-15. Even the most bolt-action rifles have an average accuracy of 1.8 MA under ideal conditions, even with much great ammunition. Let me repeat that individual groups of 2, 3 or 5 shots don't show anything. The fact that you or your friend managed to shoot a small group up to 100 meters with a short semi-automatic rifle with red dot sight, where the red dot is 6 times larger than a penny that you wouldn't see at 100 meters anyway, does not mean that you have a super rifle or you are a super shooter. It's just a coincidence, an exception, and exceptions only prove the rule. Neither you nor your rifle can be more accurate than an ultra-heavy custom setup and an even heavier rest, and people who have been hand-reloading ammunition for years to be the best. Even if the entire group lands bullet on bullet, it's still a fluke that is unlikely to happen again. Also, to weed out the comment that the barrel got hot during the test, watch this video. All the rounds were fired in 6 separate sessions, each lasting an hour, so it's unlikely the barrel would have to heat up to 300 degrees. A similar barrel heating test was conducted by MDT, and they only observed a loss of accuracy closer to 1000 continuous shots with a hot 6.5 Creedmoor. Despite this, after cooling, the accuracy returned to a relatively normal level. So when a shooter fired 1000 rounds and since the barrel overheated and that's why the group size increased, it's more likely a case of incorrect cause and effect reasoning. The group size increases not because the barrel heats up for multiple shots, but because many shots are fired at the same target, or according to the theory of probability, there may be less successful groups than those at the beginning. I divided my accuracy results into 3 stages. Unfortunately, the graph denotes have enough data on all the rounds because I didn't shoot more than 2 groups in all 4 configurations for each ammunition. But after determining the coefficients from the first objective, we can insert them into the table and perform an approximation. We will also allow the use of rounds from just one group. Thus we move on to the second stage, approximation. After shooting about 620 rounds, I got this ranking graph for the suppressor. Here 2 peaks are immediately visible. The first is GG55, which we already discussed in the section on muzzle devices at the beginning. The next peak is Cellular Bullet 55, which show a terrible accuracy based on just one group. If we sort the accuracy by muzzle brake, then with the current coefficient, the most accurate bench would be STS 55. Therefore, I had no choice but to shoot another 100 rounds to slightly normalize the graph. But here a problem arose. I no longer had the 30x scope. I had to return it to manufacturer due to a defect. Namely, the reticle marking was shifted to the center of the mark. It was impossible to zero, as the zero on travel was strictly X. The turret was slightly loose, and the image was unclear, causing double vision. For example, with Vortex Venom scope, at the distance 82 meters you could see the bolt to the left of the target and even identify its model, specifically as Phillips bolt. Whereas with the Citadel scope it feels like you are looking through a plastic bag. Interestingly, this defective scope was mounted on one-piece mount from the cheapest scope from AliExpress, which after a year of normal use didn't survive this full auto fire and became a maraca. As a result, it later became the subject of a bullet penetration test, but even with all these 4 defects on a cheap mount, it still held 0 and allowed to achieve very accurate shooting. But let's get back to the accuracy and the lack of scopes. Fortunately, I had another scope, but unfortunately it was zeroed for a 50 caliber and I didn't want to spend money on re-zeroing it again. The other scope Venom has very low rings and it won't fit on AR-15, so let's apply some Ukrainian ingenuity and use modern technologies. As a solution, I came up with the idea of making an adapter from the optics of my phone case from my previous video review on telescopes. I also suggest you to take an interest in the topic of 3D engineering, but be careful, because while in Ukraine the laws are now strict than in the US, in fact we don't have any law on this, just a regulation which doesn't apply on civilians, you could still end up in trouble for some unexpected fragile piece of plastic, even though there haven't been any precedent yet. So to avoid being the first, it's better to not print, or if some happens to be printed, don't keep it at home. Returning to the test, to avoid the factor of unstable holding, I won't hold the rifle at all, using the free recoil methods. I plan to shoot the main contenders, especially the GG55, which most distorted my graphs, plus a new batch of 24-year GG65 and Silver Bullet 69. I decided to give them another chance.
Ще не йде.
Не йде.
Не йде.
Не йде. Зараз піде. Зараз піде.
The new batch of GG62 performed just as poorly as in previous test. The same goes for Silver Bullet 69. It looked like this. I am in one spot, but the bullet lands somewhere else entirely. Interestingly, that again, the GG55 with suppressor performed worse with muzzle brake. But by mean and radius, there is no difference anymore. I also added a test with Angry Fish model, and it's interesting that accuracy of these 20 rounds was the same as with the bare barrel, although by mean radius it will even get worse with the suppressor. However, it's clear that the shooting isn't enough to draw a significant conclusion. Looking through the phone screen and using 3x optical plus digital zoom, the accuracy and aiming speed became similar to the 30x scope, or even better, which justifies considering this test on par with the 30x scope. And now the graph is more scientifically substantial. Unfortunately, the well-known peak with GG55 didn't disappear or even added a new one with the GG62. I approximated their accuracy at 2 MOA, but they show at 3 MOA. Fortunately, the Silver Bullet 55 peak, which was based on just on one group, disappeared at least. If we sort by muzzle brake, the STS-55 took the lead with approximation of 0.86 MOA for 5 shots. But the additional test with the phone adapter calmed them down. And to avoid such situations, let's sort the rounds by the average value of all 4 configurations. Now the difference is minimal, the top 10 places are the same. It is also visible that the less accurate the rounds are, the more the graph starts to vibrate and oscillate. But we substitute the value by mean radius, there will be a shift in the silver and brown places, and the Sierra bullets will take almost entire podium. It might seem like this is a correct method, sorting by mean radius, but if, for example, we compare accuracy by muzzle brake, the GG55 take first places again, by mean radius. And if we were shooting in groups of 3, the first places would be taken by Federal with Sperger bullets, but here it's a bit of manipulation, because if we take the data of groups of 3, we discard 2/5 of the data, and without the entire dataset the result may differ. And to burden you even more, we can add the rating of groups of 10. Many people determine accuracy this way. So here the usual groups of 10 combined in Photoshop if they were shot on the same sheet. But in this way we discard even more data. So here are more graphs to make my words seem more solid and scientific. Choose the ranking graph that you believe is correct or the one that better fits your worldview. For me the most accurate rounds turned out to be the GG with Sierra bullets, as they rank first in the most of the graphs. And this isn't surprising, as the company was founded by former US Army shooters who participated in World War II and began their story in 1947. It was the first company who built an underground windlass shooting range at 300 meters for its technical processes. In the US, Sierra and Berger bullets are generally used by professional PRS shooters. Berger bullets are considered better in terms of ballistic coefficients, but Sierra bullets are more stable. The Federal rounds in my test, by the way, were loaded by Berger bullets, but they didn't perform as well as the Sierra, despite their high prices. Also, the 70 grain Sierra Machkin bullets are used in the Mark 262 cartridge, which has been adopted by the US SOCOM. In one battle at distance 700 meters, only 2 American Special Forces soldiers in ambush killed 75 Taliban fighters, making just 77 shots with Mark 262 rounds. Another interesting point about bullet weight and twist rate. The heavier the bullet, the harder it to spin and stabilize it. Therefore, there are tables like this and similar ones that claim that with specific twist rate and bullet weight, the bullet will fly better. So, if you have, say, an 8 twist, the bullet in the green zone will be better stabilized. In reality, you can even overstabilize the bullet, which negatively affect accuracy. And within the scope of my test, I saw a chaos and a lack of a correlation between bullet weight and twist rate. Moreover, for some reason, the lighter 55 grain bullets flew even better than the heavier ones, even though all these tables say the opposite. Why do they still make these twist rate and grain tables? At the very least to prevent the barrel from bursting. If you use a heavy bullet and try to push it with a maximum charge, the pressure behind the bullet starts to rise very quickly. The bullet encountering the resistance from the rifling increases this pressure, and if the rifling is too steep, the bullet can get stuck, and the pressure could rupture the barrel. That is why progressive rifling exists. It is used in artillery and anti-aircraft guns, where the heavy projectiles are involved. However, using progressive rifling in small arms negatively affects accuracy because it cuts into the bullet. It cuts because compared to the initial rifling on the bullet, there is recompression by offset rifling, causing gas leak and play. In addition to the bullet weight, there is also a correlation between twist rate and its shape. The sharper the tip and the longer the ogive, the lower the drag. But such bullets are harder to stabilize and require higher twist rates. Minimizing the twist rate reduces dispersion errors by minimizing the shift in the center of gravity. However, making a bullet too long isn't an option. In classical ballistic, it is believed that it is difficult to stabilize a spin of bullet whose length exceeds 5 calibers diameters. Since the main purpose of the test is to find the best round, let's try to determine it. If we apply a purely military method by multiplying accuracy by the cost per shot, we can find the relative cost unit of accuracy. The prices are based on Sprint 24, but the editing was finished just now, because I got caught in a production hell. Let's return to the graphs. In all 8 sorting options, SCS-55 came out as the most optimal. Even if we sort purely by price, we can see the Mariana Trench over them. By the way, if we use a group of 3, the trench is still there, although the clear trend of decreasing group size with increasing cost of the round is not as visible. It's more like an oscilloscope beam that is noisy with parasitic signals. Before the test, I thought the Cellar Ballot 69 would be the winners, because despite their relatively low cost, they have a longer and sharper tip, and if they are longer, they are heavier, making them less prone to drift. Plus, the sharper the tip means better aerodynamics, hence a better ballistic coefficient. They lose less speed and therefore should be more accurate. But why didn't it work? Let's figure it out. How are rounds usually made? Copper is stamped into a cup shape. Lead is placed inside, and it is crimped, usually from the rear side. However, in this area, due to the high pressure and temperature, metal can erode, making them behave unstably. For better accuracy, they need to be closed from the rear, which is an additional process and consequently increases their costs. An alternative is crimping from the front, creating a hollow point or more correctly open tip match bullet. Although it might seem at first glance that the open tip could increase air resistance, in reality it plays a critical role in enhancing aerodynamics. The hollow cavity at the bullet tip allows the center of mass to shift closer to the rear, providing more stable flight, similar to how arrows or darts work. Incidentally, these are no longer banned by the Hague Convention, unlike the expensive hollow points and dum-dums. But unfortunately, with my rifle, the Cellar Ballot, particularly 69 grain, shoots terribly. I'm not saying the Cellar Ballot is a bad company. Other calibers from this company performs well for me, especially the 6.5 Creedmoor. However, with my rifle and my barrel, they don't perform well. If you also have EV-Xeon with a 60-inch barrel, they might show better accuracy for you, for the reason explained at the first sections of my movie. The GG with Nosler bullets also disappointed me. On one hand, it's actually good that Nosler performed poorly, as it indicates the test objectivity. A regular person might handle a more expensive item more carefully and try to achieve a better result to justify the extra cost. So which round are the best? According to my test, it is Ukrainian 55 grain board tail round. I fired these rounds from 22, 23 and 24 years of production, but many have concern about their consistency. So let's categorize it as a philosophical and a subjective choice.